So, hi, I'm RedBeard, and we are going to talk about serverless and Knative stuff. So, serverless, service mesh, Istio, we've got a whole bunch of things here, so let's just dive in and talk about service mesh to get started. So, service mesh is a component of all of these things. They build on top of each other, so it makes sense to kind of talk about this, where it's at, etc. Service mesh kind of means different things to different folks. I actually had some pretty interesting conversations about a month and a half ago with folks from the Red Hat networking team who were like, hey, we're building a service mesh, and it's all doing MPLS between things. I was like, whoa, doggy, like that's not the same beast. Like, overloading terms here. So, kind of where we are going with this is taking to solve problems with this. Everybody and their sister has a application server which they have put all kinds of workloads on, and then they have built their microservices architecture, or at least they aspire to. And what that ultimately means is that they're really going from a microservices architecture to a distributed architecture. So when we are building things in a distributed architecture, though, it means we've got a lot of moving parts with lots of services going all over the place. And now, all of a sudden, your security team is asking you about how you are controlling the communications between all of these components. And then you tell them, I am. And start going, oh, how am I going to do this? Before they find out. You're like, oh, well, it's on the cloud, so all of my IAM roles are taken care of there, and all my security groups for EC2. Oh, wait, that only does the services. I've been foiled again. So what we do is we introduce the concept of a service mesh. The goal there is to have a dedicated network for all the service-to-service communications. So it's pretty simple. It is not necessarily an overlay network. We've got enough of those within Kubernetes as it is, so we're not going to pile on one more overlay network. But, it starts to make a little bit more sense, at least from a technology perspective, if you understand some of the underlying components of what a service mesh, at least within the view of OpenShift/Kubernetes is. And the kind of flavor here of what we are working with for a service mesh is taking and having an intelligent scheduling of proxy services at the center of this, and then all of the kind of other ancillary components that you will need to keep everything running around that. And we'll dig into this a little bit differently. I won't say more, but differently, where when if we actually go back and kind of look at this, how one service is talking to another ultimately means that you're going to have to worry about actually capturing traces between those components. Pretty soon, you're going to start actually wondering about throughput between components of the applications, latency between those, even more than you did in your previous era of having all of this. It's pretty easy to trace latency between your HTML and one of the services on that application server. Fire up your Java debugger, you're good to go. When you're doing this across a network of machines, that becomes a pain in the butt. And that's why we start introducing things like Jaeger to actually be able to trace through all of our components. It's why we have components like Prometheus and Grafana there to actually capture our metrics and be able to visualize the metrics. This is also just how we happen to be viewing this. If you're at Uber, you're going to be looking at your actual time series storage. If you're kind of looking, if you're already heavily invested into Grafana, possibly Loki is going to make more sense instead of Prometheus. This is just, as I said, the way that we view it at Red Hat. And Kiali is interesting there in that it is a net new project created by Red Hat for visualization of the components of the service mesh itself. So it's a meta project there where on its own, it is not going to provide you anything in a standalone state. It only really brings value when you start using it with something like Istio. So, continuing on from there, we've talked about, what happens when you have that. But the real question becomes, what happens when you have that and that one team of ninjas over in the corner who refuse to write things in Java because They live in the future, and they want all of the memory guarantees of Rust. And, you know, it's fine. They're going to write it in Rust. Everybody else will catch up over time. They'll see the light, and you're stuck because you want to enable them to just take it and run with it and do things 5 times the speed as every other team. But you also don't want to necessarily force all of the other worker bees to change what they're doing, because they take those existing apps and they make them run. What do you do about that? Well, ultimately, it is easiest to try to address the complexity of those problems at the infrastructure level. And what I mean by that is, rather than being in a state where you have a bunch of different libraries that you're pulling into every single one of your application components, and then that team building things in Rust goes, oh yeah, I can't use those Java libraries, so I'm not going to be participating in tracing, and I'm not going to be participating in any of the service discovery or anything else, but it's fine, because we're smart, and we're going to do it ourselves, and we're going to completely reinvent that wheel, and then you get to kowtow to us. Nah, man. That's not happening. What we will do is we will take all of those things and we will push them down to an infrastructure layer so that you now say, nobody has to pull in those libraries, and that's fine. Doesn't matter if you're on Rust or Java or Go or Node or whatever. We will take those things and kind of inject them at the actual infrastructure level, and everything will be good, says RedBeard, because I'm not running your infrastructure. Oh, sorry. Oh, that one fell over flat. So how are we going to do this? We are going to do this through a series of sidecars. So most folks are familiar, you schedule things atop Kubernetes in pods. What we can do with that is we can actually collocate multiple containers together within a single pod. One of those things that, like, academically, we all understand that. At a practical level, we generally don't use it all that much. But here is a case where now we can take and put a proxy into the actual pod that our application components are running in, and schedule it in such a way where it is actually mutating the network namespace of that pod and controlling the ingress and egress of traffic from that location. And we'll talk a bit more about how that does that. So what this begins to look like is we have, as we do with any good distributed system, a control plane and a data plane. A failure of the control plane does not affect the running of the data plane. Jaeger falls over, your application does not. Pilot falls over, your application does not. Mixer falls over, your application does not, unless you've told it to fall over because you absolutely want a die-hard enforcement of policy where you want things to fail closed because it's better to make sure that everybody gets locked in that building on fire than allowing them to get out. Strike that, reverse it. So what this begins to look like in the context, though, of OpenShift writ large, or Kubernetes in general, is we actually put these in place, the control plane and then those services that are getting injected at the network level, in between OpenShift and your applications. What this means is that now, just because you use Kubernetes doesn't mean you have to use these components, while at the same time they can be enabled on a project-by-project or a namespace-by-namespace basis. So now you can have these teams of individuals begin to opt into the use of all of these components without prescribing it across the entire organization. And the reasons why you're going to do this begin with one of the most important ones, and that is fault tolerance. So now we can put in place an idea of circuit breakers directly at the infrastructure level. So for anybody who has mucked around with their house, you'll know that when you try to draw too much amperage over a wire, a circuit breaker trips. Why does that happen? Well, we decided a long time ago through the National Electrical Code that we would rather have pieces of hardware fail than our houses burn down. Rather than drawing so much traffic through that copper that we actually cause heat and then the heat causes fires, we decided, we would rather have things fail in a known, predictable way so that we can react to those failures. And that's the same idea as a circuit breaker. So now we can actually implement these circuit breakers at the network so that when a service fails, for example, all communications between service B and service C stop, we can actually work around that so that we can say, you know, it would be nice if service C ran, but ultimately we can make it work if service A bypasses that and goes around it. Because, for example, we would rather have better response times, or we don't really need that one little bit of telemetry that we would have gotten off of service B. It is better to fail in such a way where we actually bypass that than get stuck in a hung state. It also means that we can actually implement timeouts and retries at the network level rather than having to do it in the applications. So, you know, that one component there in the middle, you know, service B. Ugh. The developers of service B, when are they going to get it together? They just will not fix that memory leak. And because of that, everything starts blowing up. And then when it starts blowing up, we know that, like, if you just try it again, the pod's going to be recycling about 3 times a minute. So, you know, let it retry about 15 seconds later. It'll get to it. Everything will be fine. I mean, sorry, I'm just speaking about organizations I've consulted with in the past. I know I'm not talking about how any organizations here work. But I'm saying it's possible when you do run into those edge cases to fix that. Or being able to provide rate limiting. Again, service B just keeps getting me down. Just cannot handle the amount of traffic. So, you know, we have to scale it differently and work around it. So, you know, we can rate limit it at the network level. You know, what is happening there behind the scenes is that service A has, in its configuration, I'm going to make a request to service B. And then the proxy component, known as Envoy there, actually sees that that request is going to be made and chooses an endpoint and directs it to that endpoint in such a way where the only way that service A is able to egress that pod is through the proxy itself, which we'll touch on here in a little bit when we talk about the security, but it's how we're able to actually provide guarantees around rate limiting here. And as said, security. So, has this ever happened to you? Managing a CA via the CLI, the command line interface, where you now need to begin providing attestation of all of your workloads because you need to get to the point of having a zero trust network, et cetera, et cetera. And how do you attest these workloads? Easy, your security team. You send them a whole bunch of information. You send them the product requirements document, all of the names of the developers who are working on it, copies of their driver's licenses, etc. And now you know that when they get around to it and they click the button or run that command line interface command, and then they send you that private key insert, oh, they've already messed it up. You never transfer private key material over the network. So, how do we get around this? Well, what we do is we have the pods themselves actually use the attestation mechanisms of the Kubernetes API to be able to do this. And in parallel, we actually utilize the components of Istio to actually schedule a certificate authority that is there only to be used by the service mesh. This is not for end users on the internet to be able to reach in and talk to your individual endpoints. This is not for, you know, components of your actual enterprise software stack to be able to reach directly back to things within the service mesh. This is for service A to talk to service B and to know deterministically that it is talking to service B and to nothing else. And because this exists solely for the use of the service mesh, it means that the components of Istio can actually utilize the Kubernetes API to say, I know that the service account for service B is the only user who should ever be using this client certificate. And because of that, I will allow service A to create a certificate signing request and an RSA private key. And then we will allow for that CSR to be transferred across. We verify that it was created by the service account that we thought it was, and then we issue the public cert. Hunky-dory. Now we have automated mutual TLS authentication transparent to all of these services. What it ultimately looks like for folks who are familiar with this is something kind of like S-Tunnel. Only now, rather than having these shotgun blast mechanisms of saying, yeah, configured, it'll probably be fine, we actually have components that know the provenance of all of our workloads and know when certs should be issued and when they should not, and they can take it and they can go nuts. Now, it also means that, get back over to the right window, there we go. It also means that we can now use those to control access to the services. Now we know for certain that the only service that should be allowed to talk to service C is service B. If a malicious individual happens to get into service A, and they attempt to make outbound connections to service C, which in this case may be a database component, it could be a message bus that is actually where they could watch and subscribe to a topic and see all kinds of responses coming back and forth. Now, service C can actually deny access because it is doing client certificate-based authentication and knows that that cert is just not, fundamentally not allowed to talk to service C. Now, I would also like to say in regards to these components, when I think about the historic certificate requisitioning process, because I've had to go through this recently, if you want to get a cert signed for use on the public internet, we have two basic ways of doing that right now. One, you go with one of the historic incumbents, or you go with something like Acme, which is more commonly known as Let's Encrypt. The beauty of Let's Encrypt is the automation, is the fact that it is using attestation mechanisms like DNS ownership, because ultimately, if somebody has taken control of your DNS, they're going to route that traffic anywhere they want to anyways. But also utilizing other capabilities like verifying the actual challenge response on individual services, et cetera, to be able to automate that workflow. And it works really, really well. But how many organizations have you worked with, have you worked for, that are using the equivalent of the incumbent model, which is go to a web form or file an internal ticket, request a certificate to be issued, and then wait for the ticket to get an update? Maybe they call you back a day later at a verified phone number that they found on your website. Maybe they're just going through and going, oh yeah, I can't find RedBeard in the employee directory. Clearly a malicious actor. Or some other verification mechanism like that. I can tell you that while it may be more painful at first to get on board with the automated operations mechanism there, in the long run, it is less prone to failure and more likely to provide resilience in the face of something going wrong. Because when Bob got that cert issued for that application, and then he decides to take a different job working over at Conglomco rather than your organization, and the only person who knows how that certificate mechanism works is Bob, and he isn't there to process the renewals, or his email address doesn't get the responses going, hey, your cert is up for renewal, it's going to fail. And the failure case is scramble and try to figure out what went wrong. In this case, we have robots doing all of this for us, albeit software robots, but still automated automatons which are existing with the sole purpose of making sure that those certs stay active and will rotate as quickly as you tell them to. And that brings up some interesting new perspectives, because now, hey, what would happen if we dialed those certificate renewal times down to 1 hour? Well, the robots will be able to handle that. On the other hand, humans would not be able to reissue those that quickly. And it means that in the event that you did actually have a malicious actor in your system, you can actually limit the scope of validity for which they can actually weaponize an attack. It is not to say that you remove that vector of attack, but it means that if you're in a situation where you have a giant Java application, maybe a couple Aprils ago, and you're just accidentally not patching those Java libraries, and somebody gets into that system, it means that when that cert expires, that access will be revoked, the pod will be recycled, you will bring a new one up, and they are free to try to weaponize that attack again, but they need to start from 0. They don't get to start from 6 links deep into the chain. It means that they constantly need to be now automating their own weaponization, which eventually they will. But that's the nature of what we're doing here. We are trying to work faster and stay ahead of these malicious actors. Sorry to bum you all out. But now when we're in a situation where we need to keep responding to these threats, now we get into the concepts of chaos engineering. So what I mean by chaos engineering is, I'm sure folks have heard of Chaos Monkey. But have you heard of the rest of the simian army? Have you heard of Chaos Kong and Chaos Gorilla and all of these other components? You should. The problem is that these are pieces of software that you must actively set up to take action to destroy the things in your network. Destroy the things in your network? Yes, you want to be destroying the things in your network on a very, very regular basis. Because you need to get into a position where you understand how the failures occur, what happens when things go wrong, and most importantly, the plan of attack for how you respond to them. Mike Tyson famously said, everybody has a plan until they get punched in the mouth. I'm not saying that you need to be punched in the mouth, but I'm saying having a friendly helper like your own personal chaos monkey who does not have the same force to bear behind that will at least allow you to get prepared and know what's going to be coming. So what this begins to look like is we have situations where now we can take and we can mutate the network traffic going between services, we can inject delays, do this transparent to the services so that we can start to see what happens when the delays are there. Or what happens when we start seeing protocol-specific errors. Wow, we're getting 5% of all of our total requests coming across surfacing 400s. Transient errors telling us to try again. What do we do? How do we react? Are those errors surfacing all the way back to customers? Are there useful debug messages going all the way back that really shouldn't be there? Is it dropping like the table names and everything in the... Ooh. Easier to just test these things out and go, no, we're good. We've run through this. We've seen all of it in practice. We know. And then we get into the bits that are a bit more fun. I save this for last because this is the parts that folks actually get excited about, the kind of dynamic routing aspects. I love picking on Dan Walsh. Dan is our Boston employee. He's over there happily working away on SE Linux, and we decide that all of his requests going inbound to Bugzilla, we are going to send them to a new version of Bugzilla. We're going to send him to version 5. Everybody else is on 4. So we're going to make him suffer pain in the same way that he makes all of you suffer through writing that policy. But I jest. What we're able to do here is we're actually able to annotate the requests that are flowing through our system to be more strategic about which versions of services they're flowing to. So we can say, hey, the entire world goes to V1 of Bugzilla. We're good. Or I guess in this example, version 4 of Bugzilla. But Dan and everybody else in that Boston office, we're going to send them to version 5. I shouldn't have used Bugzilla. I'm already confusing myself with the numbers here. We're able to start saying, okay, is the application working the way we expect it to? Is there any problems? Are we able to respond to things? When they click submit or they go to update an issue, is it flowing back correctly into the database? Is it having any performance problems, etc.? And then, once all of the Boston employees give us a sign-off that everything is good to go, or at least a quorum of them, we can start moving into more of an A/B deployment model, where we can go, hey, now we are going to send half of all of our users to v4 and half of all of our users to v5. We will make sure that everything looks good to go before we send the entire company over to it, and then the entire world writ large over to it. You know, this is the way that software is deployed at scale today anyway. Ever wonder how all of those updates to CoreOS images or to container Linux machines got sent out? It's just like that. We start out sending the updates to 1 machine a minute. Looks good? Let's try 5 machines a minute. Still looking good? Let's change this over to sending updates to 1% of all users every minute. It's that sort of deployment ideology of rather than just fire and forget, actually do staged rollouts so that you can hit the panic button in the event that there's a problem and make sure that the updates are not going to anybody who you don't intend them to. As you begin to evolve these ideas, it also means that you can take this a step further. And before you even get to the point of deploying those services for Dan, you can make all of the traffic go to version 5 of Bugzilla, or version 2 of the service here, and have the proxy for v2 of service B transparently drop all of the responses to the requests. Now we can actually see the service is going to handle the amount of traffic that we're going to send at it. We have a high degree of confidence that everything is going to work the way that we expect it to. And when we have all of these things in place, we now, thinking of that spider web that I showed you back at the beginning, we want to be able to trace all of the components. And so what we do is we implement distributed tracing, specifically using Jaeger, which is specifically an open source project created by folks from Uber and donated to the CNCF. You know, specifically folks from the Kiali and the Red Hat Jaeger teams have done a lot of interesting work. You know, we now have a Jaeger operator, which you can deploy via operatorhub.io. Running EKS, go ahead and deploy it. Run an OpenShift, gonna work great. GKE, no problem. Again, that's the point of Operator Hub, being able to kind of pull these components and actually be able to use them. So the tracing mechanism here through Jaeger, the idea is to get you, at the very least, a bare minimum level of functionality just by having injections done at the proxy level. Now, obviously, if your application components choose to use the Open Tracing API and maintain even more headers or inject additional information about the calls, you can actually get much more visibility into the total call depth of a multiple series, you know, a chain of services throughout your network. You know, in this case, we can see that the weakest link is, once again, service B. We look at that actual set of response times down at the bottom, and we say, man, service A, very snappy. Service B, though, it's fallen off a cliff. It's over 3 times as slow as service B. So when somebody calls your help desk and goes, the website is slow, or even worse, the website is down, you're going, man, I'm just sitting here trying to play Halo, and I know that nobody gets that joke. I knew that Ben would get that joke, but you're now sitting there with an actual thing that you can begin to measure and test and debug, which is, okay, yes, it's slow, but we see that service B is slow, so team working on service B, once again, you broke the build, please fix it. So I also mentioned observability here. So here now, you know, this is admittedly an old screenshot of Kiali, but the point here is to show you that you can actually get a graph of how all of the services are connected together. So we can see that, you know, we have communications kind of flowing downwards, going from, oh, that doesn't work at all. Yeah, so flowing down through this graph, and then when it gets from there, we have 3 different versions of the services going downstream. And that one specifically, we're getting 500 errors on. So we know exactly that that new version of that service, that V2 one, is having problems, whereas V1 and V3 are just fine. So we can actually begin to do a bisection and narrow down exactly where failures are starting to happen throughout the environment. We know, okay, it did work in V1, so this isn't just a fluke, and it's working in V3, so did we actually fix the regression there? Did it just kind of sidestep it? Did we rip out some piece of code that just happened to fix it? Now you can actually have more tooling in place to visualize these things to actually do further debugging. And now, serverless. There's your new data center. That is not serverless. Yes, there are servers. The idea is to begin to abstract the services, or the servers for your services, into things that you don't care about. No longer is this something where you care about some version of Apache or some version of Nginx, but these are just processes that are handling network requests. And the platform takes care of all of the components under the hood. Now, with that, there's a little bit of confusion, because most folks think of, they generically will swap out functions as a service for serverless computing. And those are not the same thing, because there is a lot more functionality that gets provided by an overall serverless system than just functions as a service. So, digging into this a bit further, we have an evolution here where we start with the idea of we've built these distributed services, and then we realize that we have put too many actual functions into a single service, so we break those down into microservices, where we now build a single service to provide a single purpose. And then we still have to manage all of these build systems, and we still have to scale the actual services directly, which begins to be their own pain in the butt. So that is why, a few years ago, the ideology of functions as a service were introduced, and why folks began moving things over to those functions as a service. I can tell you, using one of the major cloud providers, it became very, very helpful when we started using the CloudTrail mechanism with that public service. This is at CoreOS, by the way. And then set up a series of functions running on that network that would automatically annotate those CloudTrail pieces with additional pieces of information that were not showing up in CloudTrail. It's a very simple thing to do. Hey, watch these message buses. Let us know when there are changes, when new CloudTrail bits are actually dumped in place into, object store, and then go through and re-annotate those and let us know when there are things occurring. That allowed us to then be able to go through and automatically slurp them down, begin doing automatic ingestion of those logs into other systems, and allowed us to find problems proactively and react to problems much more quickly. It doesn't stop you from developer commits keys to GitHub, and then you're sitting there reacting to multi-$100,000 bills on said cloud provider, but it does allow you to mitigate much of the problem. So, what this begins to look like is the reason why you are moving in this direction is specifically because you are trying to focus on the things that your business is good at. If your business is not in trying to provide the kind of overall support for Tomcat, and you really just want to focus on the bits of code that you're working on, then just focus on the bits of code that your team are truly experts at. Focus on the productivity and the getting things done, and less on the degree of control that you have and which arbitrary libraries that you can vendor in, etc. So how does this start to work? Well, you have some event happening, your code runs, and then you actually emit messages or emit new events. In other words, it's a lot like the way we have been used to doing things within POSIX operating systems. Only now we have much more impressive event systems and much more sources and sinks that we can send data and pull data from, rather than just standard in, standard out, and standard error. It means that we can now use message buses to do more intelligent things and actually maintain those messages between the actual services that we are trying to run. You know, we can now have things like a process running and putting information into a FIFO and then multiple other processes watching that FIFO and reacting to it only over a network. So this is kind of where we're at. You know, this is the state of things right now. You know, we are just getting to the point where it is reaching early adoption, and we still have a ways to go, and that's okay. Because what this really means is that it's going to allow us to kind of find some overall balance of meeting the needs of what we're trying to do without kind of completely face planning on building the wrong thing. You know, there were originally some slides kind of attached to this talking about the Apache Cloud Functions, which the idea there is Apache Cloud Functions was trying to provide functions as a service. But the reality is that it did not provide everything that was needed, which we talk about in a second. So when we look at this, going back, functions as a service there are never going to be the way everyone does things. That's not the reality. It's not trying to be the reality. You know, we are going to hit an inflection point where you decide which of those is the right answer based on the need for control, which is why we get into having a bell curve here. You know, we are going to have a situation where as organizations choose which of those is the right fit, you know, we are going to see an increase in adoption. I don't know why there is the tail off on there, but is to say that we are never going to hit the same degree of adoption that we have with microservices and Kubernetes. But we do see that there has been a giant uptake in this over the past few years. So, you know, in 2014, we kind of introduced AWS Lambda, OpenWhisk. That was the Apache project I was trying to remember. I'm not the product manager for serverless computing, by the way. That is William Marquito, who could not be here today. So we go through this increasing number of options that we have available, and you know, get to the point where today we have a new option called Knative. Right there. So as we kind of dance through this, let's talk a little bit about Knative. So Knative goes beyond just the services and prescribes both a build mechanism, the serving component, and the event system. The reason why it does this is it's a recognition that if you are trying to do serverless computing, if you're trying to do functions as a service, you may be working in a programming language that requires you to build some artifact. Or you probably want to be able to pass messages between two functions or two other components. And so you need standardized interfaces for the build components and the events, etc. So the builds, all of these components are kind of being brought in as native components of Kubernetes. They're done in a way that exists in a way that would seem extremely congruent. You're going to do builds as pods on top of your cluster. You are going to pull those down directly from source control. You are going to kind of annotate the exact locations of containers and the endpoints or the container storage engine that you are going to deploy this to. For example, Quay, which I highly recommend folks check out. Similarly, you're going to now begin to build standard interfaces for how you actually serve those. You know, how you are going to be pulling in your configuration, how you're going to actually checkpoint state, etc. You know, you're going to use the actual config maps within Kubernetes. And finally, how you are going to consume cloud events. You know, that's the whole purpose here, is to begin with serving the kind of serverless type workloads, but ultimately build into kind of having cloud events available. I need to tell William to update that date, because this week was not September 5th. But also to kind of work with the Kubernetes ideologies and continue to move very, very fast. Keep up the API levels that we are familiar with and get them, in a way, caught up to where they are at with Kubernetes. You know, frankly put, break many things now when there are far fewer users than breaking everything later when you've got a lot more users. You know, it's a really crazy idea. But Knative is giving you building blocks, but Knative explicitly has decided that they do not want to be an entire platform. You know, they don't want to provide tooling just to be able to deploy functions. You know, it means that there is a lot of leeway here to be able to fix some of the more prescriptive parts of these processes through the use of operators, specifically around Knative. You know, deploying things in standardized ways that then folks know that they can then kind of build them in a way that makes much more sense. And that's where the kind of relationship between Knative and Red Hat comes in here. So now we can go in and we can say, you know, we are going to kind of use Builda and use some of our other source to image and our other development tools as the actual build services. We know these well. We know that we can support them. We know that we can provide all of the interfaces that are needed to make them successful. So we are going to conform to the interfaces that Knative prescribes and make them work. Similarly, we will conform to those interfaces for messaging and for functions as well. And when we know that we are going to now have these functions running all around, all over the network, and we know that we need to actually secure them and begin to provide better routing of them, now we have some peanut butter with our jelly. We can begin to utilize Istio and the service mesh kind of as underpinnings to make sure that all of the inter-service communications can truly exist in a zero-trust manner. And this begins to get more complex as we add more services with more events, and we trigger builds, and the snake eats its own tail, and we have a giant Ouroboros here. But it makes much more sense to me if we talk about actual use cases. So let's say that we have OpenShift, or we have Kubernetes running, we receive a scale-up event, and we go through and we actually go through and verify a quota, we update any kind of billing things that need to happen, we kind of update a specific service broker and send a message out to our billing service, and then in the event that there's a failure, we notify the on-call person, and then we fire off a function that opens a specific Jira ticket, possibly including a trace or some other information, and then actually fire off new pods to react to that, so that now we have automated recovery of the services, while at the same time knowing that all of the telemetry that we needed has been captured and put into that Jira ticket. It also means that we can do things kind of like I talked about before, only now rather than my team needing to build this like happened back in the CoreOS days, it means that these are now Lego blocks that we can just assemble together. We can say, watch a file system, put things onto storage, and then do some mutation, or take an image, figure out what is actually happening in it, perform any kind of mutations that need to, and output a new image. Means that we can kind of build more complex services that we have been used to, and also building the next generation of services for more complex use cases. I mean, imagine a world, if you will, where you have jet engines. We've got a lot of those, manufactured by companies like Rolls-Royce and GE and things like that. And there are thousands upon thousands of sensors in those engines. What happens when you begin capturing the telemetry of all of those sensors and correlating over time that, when this part has failed, we see 3 weeks earlier that this vibration sensor started going off. Now, rather than having your planes be offline because the part finally broke, you know with a high degree of certainty which parts you proactively inspect and replace. You can actually go through and have those parts drop shipped to the airport before the plane even lands, if the parts aren't available, or potentially react to scheduling changes to make sure that you have the planes in flight, ready to go, to react to changes as they occur. Because this is how businesses need to be operating to truly keep up in the third decade of the 21st century. Just over a year off from the third decade of the 21st century. You know, Ben asked earlier, hey, how many of you remember my "I can't believe it's not butter" joke? Well, the reason why a bunch of you don't is because we are almost in the third decade of the 21st century. So, just keep that in mind. As an aside, it reminds me of the very tragic moment when the former VP of Operations from CoreOS congratulated me on my 35th birthday and said, "Congratulations, you're now closer to 50 than you are to 20. And I went, oh. Thanks, man. Thanks, Jeff. Always there for me. But all of these things are great for building chatbots and data transformations, packet processing for voice, and things like that. So be thinking about this. You know, just because the technology is there doesn't mean you have to use it, but just because you aren't using the technology also doesn't mean it's not there and won't continue to evolve. And as technologists, it's up to us to be aware of what's possible. You know, the times when you don't want to use this are super long-running tasks that can't be checkpointed, or, you know, things that can't deal with, you know, a delay because you actually have to scale them up. And where are some of these things going in the future? Well, this is easiest for me to speak to when I talk to the service mesh components, since that's the thing that I'm the PM of. And that is that we are going to GA with that in May. It's exciting. GA of Service Mesh. All kinds of sales folks and folks keep asking me. We are going to have the 1.0 release of OpenShift Service Mesh, which is really the 1.1 release of Istio. And then the thing that's exciting to me is that we are kind of taking our process and drinking our own champagne. We are trying to build our update mechanism as one of the first ones that is doing an add-on component that is critical to users of OpenShift, but receives operator lifecycle management-based updates. So this is to say the idea that even on your own clusters of machines, you subscribe to updates in a very similar way that you subscribe to like RDS updates atop Amazon. You trust that there are channels of software available, that there is, you know, a tech preview channel, a stable channel, and an LTS channel, and that you can subscribe to those channels, or the master one if you're feeling dangerous, and receive those as a continuous stream update. And that's about all I've got to say, with the exception that, you know, we are also going to be working on integrations with 3Scale, which is a API routing mechanism, you know, kind of building in hooks into the Istio component of Mixer to kind of make sure that, you know, we can minimize some of the duplicated components and make sure that you take the kind of routing capabilities that are available in Istio and continue to build on those with more types of policy enforcement, etc. And with that, I yield the floor. Thank you very much.